This video is going over mathematical modeling for Chapter 2 in Honors Pre-Calculus. We're going to go over problems 1 and 2. A rancher has 200 feet of fencing to enclose 2 adjacent rectangular corrals. So the first thing we probably want to do in a problem like this is draw a picture. So in order to have 2 adjacent rectangular corrals, we have one rectangle, and then we would draw another fence somewhere in between, and it doesn't really matter where that fence is, because when you add these 2 areas, it will always be the same no matter where you draw this. These 2 areas will always be the same, so it doesn't really matter where we draw it. So we have 2 lengths and 3 widths. So if I add the 3 widths and the 2 lengths together, that has to add up to 200 feet. So that's the perimeter, essentially, including that part in the middle. So I have 3W plus 2L equals 200. And then my goal is to find the maximum area. So I have to find another equation for area. So area equals length times width. So in order to get this into something that's easier to graph, I'm going to solve for one of the variables. So I'm going to solve for L. So if I subtract 3W and divide by 2, I get 200 minus 3W over 2, which I can also rewrite as 100 minus 3/2 W. So I can now replace the L in my area equation with 100 minus 3/2 W. So I have W times 100 minus 3/2 W. That's something that I have as an area equation, or I can multiply it out and get 100 W minus 3/2 W squared. So now this is going to be what I type in the calculator in order to figure this out. So I'm going to let X represent my width and Y will represent my area. So then I graph it, and I've already changed the window to be something where it works. So you're going to want to make sure you change the window. Then in order to find the maximum area, you would hit second calc. So second trace, that gets you the calc. And then 4 is the maximum. Make sure you put the cursor to the left and to the right of the peak. So it has to bound the peak, and then you hit enter. And then that will give you the maximum. Now there might be some slight rounding error when the calculator does it. Notice that this is 33 1/3 for my width, and then the maximum area is 1,666 2/3. So that will give me the information that I need. So my width is, what was it again? 33 1/3 feet, which we tend to not like to write mixed numbers. So 33.333 feet. You're allowed to round to 3 decimal places anytime you use a calculator. We can also write this as a improper fraction. So that would be 100 over 3 feet. And it's asking for the dimensions. So that means not only do I have to provide the width, but I have to provide the length. So I will take this and I will substitute it in here. So 100 times 3 is 100. So 100 over 3 times 3 is 100. So 200 minus 100 divided by 2 gives me 50. So my dimensions are 50 by 100 over 3. It doesn't ask for the maximum area, But if we wanted to report the maximum area, we would say it would be that amount of feet squared. Now you can also use Desmos for this. So you can type this in here and it just gives it to you. But again, Desmos is not usable on any sort of standardized test or anything. So you have to make sure you know how to use your TI calculator. Problem 2, an open box. Smart is really annoying sometimes. An open box with a square base has a volume of 100 cubic feet. What is the minimum surface area of the box? So again, we're probably going to want to model this with a picture of some kind. So I have some sort of box. It has a square base. So that means both of these have the same length. And then the volume is 100 cubic feet. Also note that this top is not really there. It's an open top. So I only have 5 sides to this box. So it has a square base. The only thing I don't know is how tall this is. So in order to find out how tall this is, I'm going to replace this with h. And so I know that the volume, which is 100 cubic feet, is equal to x squared times h. And then I also know that I want to find the minimum surface area. So I'm going to make an equation for surface area. So there is one floor of this that has area x squared. And then there are 4 sides to this that all have area x times h. So in order to figure out what this is going to look like, I'm going to solve this equation for h. So h equals 100 over x squared. And now I can take this and replace h in my surface area formula. So the surface area is equal to x squared plus 4x times 100 over x squared. So I can simplify the surface area to be x squared plus 400 over x. So x squared plus 400 over x is going to be my surface area. And I have already typed that into my TI calculator. And this is the function. So I'm going to hit second trace, which allows me to calculate. Then I'm going to hit 3 for minimum, or I can just scroll down to minimum. Then I want to make sure that I include the minimum when I'm doing this. So I'm going to make sure I bound the minimum. And it appears that the minimum is at 5.848, 102.598. Likewise, that's true on Desmos. 5.848, 102.599. And I probably should have rounded that to 9 also. So now I can figure out that that is x. So x is 848 feet. I can find the height if I want, but it doesn't actually ask me to. And then the surface area is what it's actually asking for. So then all I have to do is report 102.599 and make sure that I get the units correct, feet squared. So the volume was in feet cubed, which means everything else is in feet. And all the sides are in feet, and then the surface area is in feet squared.